done so well by clicking on this video. This is Winkle's class and I welcome you back once again. If you are here watching this video, then I'm sure you have gone through the previous episodes. If not, the link to the previous episodes is in the description box. You can go there, click on the corresponding video that you want to watch, and then you can go and watch it to get the understanding before you come to the fourth episode. Okay. Alright. Today's content represents the episode 4 of Understanding UV-Visible Spectroscopy. And before we dive into it, I would like to remind you of the fact that you have to subscribe to the channel in order to help us grow. As well, you need to try as much as possible to like the video after watching, and you can also share it with your friends as well. Don't forget to turn on the notification bell so that any video that I release, you'll be able to get the notification and then watch it in due time. Alright, so without wasting much time, let's look at today's content. What do we have here today? The selection rule. Understanding UV visible spectroscopy, episode 4. Yeah, so if you have gone through the previous episodes, we have spoken about a whole lot of things. We spoke about how electronic transitions occur, the kind of electronic transitions that are observed, what they mean, how they usually occur, how the electrons get to jump from one energy state or energy level to the other. And we've also looked at the major organic functional groups and their corresponding electronic transitions as well. And today we want to just build up a bit on what we have learned so far. Yeah, the selection rule is something very simple and then quite easy to understand if you just follow the principles and then you watch the video carefully. I'm sure by the end of this video you should be able to understand what the selection rule actually means and how it is relevant in UV visible spectroscopy. Alright, so as we usually do it, I would start by trying to explain to you what the selection rule actually is. Okay, so what do we have here? In the slide, we have the fact that the selection rule is a set of principles or conditions that dictate whether a particular transition between quantum states is allowed or forbidden. So this statement is quite simple. Let me try to elaborate on it a bit. So it is just like when you come to the university system, okay, you come to school, and for you to be able to transition from maybe from your first level, which is level 100, to level 200, there are certain courses that you need to take, okay, and then when you take those courses, it is a must for you as a student to pass each and every one of those courses. Yeah, so let's say that the transition rule, the selection rule, okay, in this scenario is the fact that you need to pass, you need to be able to pass all the courses that you have done in a particular semester. If you fail even one of the courses, you need to rewrite it again and make sure you pass it before you proceed to the next level. The same thing applies to the selection rule in UV visible spectroscopy. It is just like a set of regulations or principles that guides the kind of electronic transitions that are allowed to happen or occur, or that are allowed to be observed. Okay, so from the last episode, I mean the episode 3, I made mention of the fact that it is not all electronic transitions that are observed, even though a lot of them occur. Yeah, so the same thing happens here. There are several electronic transitions that occur, but then it is not all of them that are allowed. Okay, if it does not follow or does not obey the transition rule, then it is forbidden. Right? We call such electronic transitions forbidden transitions because such transitions actually have not followed the selection rule. They have violated it, and therefore they are not allowed to happen. Right? So that is just the basic explanation I can give you, and I think with this explanation you should be able to understand what selection rule is, and when you meet it elsewhere, at least you will know what you are reading and what you are expected to know from that. Thank you. Let's move on to the next slide. we have examples of the transition rules over here. Why do I keep on mentioning transition rule? Yeah, don't mind me. Let's get back to the content. So we have a specific example of the selection rule over here. We say that transitions in which there is a change in the electron's spin quantum number are considered forbidden and are not permitted to occur. All right. So that is one of the selection rules. Okay. For an electronic transition to occur, one of the rules that apply to it is that the electron that is undergoing the transition must not undergo any change in its spin quantum number. Okay, once there is a change in the spin quantum number of that electron, then that particular electronic transition is not meant to occur. It is forbidden. It has not been approved to occur. Okay, that is the explanation or the major understanding that you can pick from these statements. All right, so they ask you, name one specific example of a transition that you know. Just say in your own words that one of the rules says that for an electron to be able to transition accurately from one energy level to the other, it must maintain its spin quantum number, right? The spin quantum number must not change. Once it changes, it means that that transition is forbidden. Okay, now what is spin quantum number? You might be wondering, spin quantum number. I know maybe you've heard it before, but then just to recap or to just draw you back a bit on what you already know, spin quantum number actually describes the direction of the electron spin. Like, you know, electrons on the shells, okay, on the shells of atoms, they move around the nucleus of the atom, just like how the planets move around the sun, right? Yeah. So this is the fact here. When the electrons are moving, they don't just rotate around on the shells like that, but rather they spin on their own. They have their own axis that they spin on at the same time moving around the nucleus of the atom. Okay, now that spinning process, okay, we have a characteristic or we have a figure that describes it. We have a symbol that describes it. We have a system that describes that kind of spinning. How is the electron spinning on its own axis before it moves around the nucleus of the atom? That character or that system is what we call the spin quantum number. Alright, so when you have the spin quantum number, it tells you how the electron is rotating or spinning on its own axis whilst it moves around the nucleus of the atom. Okay, that is what we are trying to look at over here. Alright, now when you take electrons on their axis, they either spin clockwise or anti-clockwise. Alright, and when you follow the cursor very well, you can see it from the diagram here. On your left hand side, you could see that there is one. I have a circle with an arrow pointing up here, just trying to tell you this just depicts an electron. Okay, so this the upward arrow is the electron facing up, and then this just kind of signifies the axis of rotation. Okay, so if the electron is pointing upwards, all right, or it is rotating this way, then we say that the electron is spinning in a clockwise direction, or we call it a spin up. Okay, you call it spin up. That is if the electron is pointing upwards or is rotating or spinning in a clockwise direction. All right, and with that we represent its spin quantum number with a plus half, that is positive 1/2. Okay, so whenever you see a spin quantum number of plus half, it indicates that the electron is spinning clockwise on its own axis, or it is pointing upwards in terms of representation on the orbitals. All right, now when you look at the one on your right, you realize that the electron is pointing downwards, and then the spinning is kind of like counterclockwise, you see. So this is what we call the anti-clockwise spin or the spin down process. All right, and this is represented by negative half. All right, so whenever you see a negative half, it tells you the electron is pointing downwards. When you see positive half, it tells you that the electron is pointing upwards. Right, so you realize that when you take the how do we call this, the molecular orbital diagram. Okay, the electrons on the orbitals, all right, one points upwards and then the other points downwards. So right, two electrons occupying, like we usually have two electrons occupying one orbital like that, or one level, one energy level like that. So if let's say we take a molecular orbital like the sigma orbital, all right, sigma molecular orbital, that is the bonding molecular orbital. If you have two electrons, one pointing upwards and the other pointing downwards, if one of the electrons has to jump to a higher energy level, all right, that electron must not change its spin quantum number. And I hope by now you understand why. Because let's say if this electron is pointing upwards like this and it makes the jump to the higher energy level, it is not supposed to change and come and be pointing down this way. No. So for us, it was up, or it was spinning on a clockwise rotation over here. Once it jumps to a higher energy level, it's supposed to maintain that same manner of rotation and then point upwards. Okay, so if it was this and it jumps and it becomes this, that kind of transition is forbidden. That's what we are trying to talk about over here. Okay, now let's see what we have in the next slide. There are other rules that makes up the transition rule. Okay, other ones actually talks about the number of electrons that can be excited at a time. So you need to be mindful of the number of electrons that are being excited at the time. We don't expect more than a certain number of electrons to get excited. You know, diving more deeper into this particular concept is not really relevant in this course that we are dealing with. So this is just to give you the fair knowledge about what selection rules are. So I'm not going to mention specific figures over here. All right. Okay. So yeah, so you need to be mindful of the number of electrons that gets excited at a time. It is also part of the selection rule. Okay, you will get to know the exact numbers and then exact figures, calculations here and there in quantum mechanics. All right. Now there's another thing. We can also talk about the symmetry properties of the molecule and then the electronic states. Okay, when we talk about symmetry properties of a molecule, what does it mean? Symmetry in quantum mechanics is kind of like the thing should remain unchanged. Okay, like it should be equal. The way it was initially, it should be the same way when the molecule undergoes some kind of operation, all right, or transformation, let me put it that way. So for example, if the molecule is, let's say, in a particular shape, let's say if it is rectangular and the molecule undergoes maybe rotation, reflection, or maybe any kind of transformation, then the molecule at the end should also remain that rectangular. It shouldn't change. When that happens, we say that the molecule has obeyed the symmetry rule, right? So when you are looking at selection rules, we kind of like take the symmetry properties of the molecule into consideration. We want to see if the molecule has that ability to maintain its specific characteristics even when we have done some translations or maybe some modifications within the molecule. Okay, for example, if let's say we have water molecule, okay, we have water molecule. If we are able to transform the atoms within the molecule, you know, water has two hydrogen atoms and then one oxygen atom, right, making it the molecule, right? So that there are three atoms within the water molecule. If we transform any of the atoms within the molecule, we don't expect the molecule to change certain characteristics. So if the molecule has the ability to maintain those specific characteristics regardless of the changes that we make in the molecule, then we say that okay, the molecule has obeyed that rule of symmetry, right? So when dealing with selection rule, we kind of look at the symmetry properties of the molecule as well. The same thing applies to the electronic states. We don't expect certain changes to occur within the electronic states of the system that we are dealing with. All right, so you keep that in mind. Yeah, let me just put it that way. You keep that in mind. That is one thing that you can talk about in terms of the symmetry properties. So nothing should change, or certain specific characteristics must remain constant regardless of the changes that occurs in the system. All right. Okay. Now let's look at what we have here, we have allowed transitions and then forbidden transitions. I think when I was giving the introduction, I made mention of some the transitions being allowed and then some being forbidden, right? Yeah. So the transitions that are allowed, you know what that means already. All allowed transitions follow the selection rule, and then the forbidden transitions do not follow or they violate the selection rule. All right. So, for example, if let's say an electron jumps or makes a transition and then its spin quantum number ends up changing, or the molecule, the electron that transition within the molecule end up changing the the particular or specific characteristics of the molecule, then we say that that kind of transition is forbidden. Okay, what do we have here? Note that in certain cases, forbidden transitions can still be observed even though at low intensity. Yeah, so as I said earlier on, forbidden transitions can occur. Okay, sometimes they can occur, just that the intensity might be low. You wouldn't be able to see or observe it as clearly as you observe the allowed ones. All right, so some forbidden transitions, when the right conditions are met, you realize that they can occur, but then the intensity will be low. So if you look at the results, maybe the peak that would give you maybe in the chromatogram or something, you end up seeing that the peak might be low, the intensity will be very small as compared to the intensity of the allowed transitions. All right, good. So thank you very much for watching this video, and I think you have understood something, and you have taken something positive out of this video. I pray so, because this is just a build up on what we are going to be looking at, and it is meant to just prepare us for what we have in the future. There are several things, several videos that I'm going to release based on this particular major topic, that is UV spectroscopy, and then I pray that you find the strength to stay tuned until the last video. Thank you very much once again. I'll see you in the next episode. The next episode will talk about something that I wouldn't want to mention, because I want to keep you curious. I want to surprise you with what is coming next. But if you are following, from the beginning, then you would be able to predict what will come next. All right. So I'll see you in the next episode. Thank you very much. Bye bye.